geometry students, we're going to run through section 3.6 a little bit. It is okay if you do not include notes of this because the notes are a little bit easier to take if we're in person. And part of what I need to do is just talk about it so you can get through the problems and feel confident. The term equidistant means equal in distance. So when we talk about equidistant, we really just mean if I say that my house, which looks kind of strange, my house is equidistant from my favorite store, Aldi, and my other favorite store, I don't know what other favorite store, Goodwill, there we go. If I say my house is equidistant from Aldi and Goodwill, it basically means that the distance from Goodwill and the distance to Aldi would be the same. That's what equidistant means. All right, so a couple of concepts that we need to talk about. If you have a point and a line, and you want to talk about the distance from that point to the line, and this is a natural thing, but like a thing that you would automatically think about, but of course in geometry we need to spell it out. The distance from a point to the line is the perpendicular distance. Basically, it's the shortest distance from that point to the line, which is going to be the perpendicular distance. I wouldn't say the distance from line AB to line C is like 5 miles. Like I wouldn't choose the slanted line. I would choose the shortest distance or the perpendicular line. We have a little postulate. So if given a line and a point not on the line, there exists exactly one line through the point that is perpendicular to the given line. There's only one line that can go from this point to this line, and that's going to be perpendicular. And so that's just something we accept and we understand. What we had, and I'm going to skip this example now, is this example which talked about basically finding the distance from this point or drawing a segment that was the shortest distance. And so we'd have to use a little bit of our construction skills. And I'm going to skip that now because it's not that hard, but that's not the crux of what you want to be able to do in this section. So you can kind of read through the example in your text. It's a good example. It's fine. Shows you how to make an arc and, make another point so that you know that you're making a perpendicular line through this line through point A. So I'll skip example 1 and I'll go on to example 2. Let me see if I can find it. All right. So here is example 2. All right, so we're going to look at the distance from a point to a line on a coordinate plane. So in this example, these examples are a bit extensive, so I want you to follow along carefully. You might want to take notes, not so much that you can show them to me, but that you can have them to handle the rest of the problems. So you've got to find, we're going to find the distance between L and this point here. Sometimes it's really helpful just to have a drawing, so I'm going to draw a little diagram. It's not going to be the perfect, most beautiful picture, but it'll at least give me an idea of where things are. There, so that's my crude drawing of what's going on. And so I've got this line L down here. Here's point P. And I want to find the distance between these 2 points. So between this point and the line. So basically, I need to figure out this line here, figure out what this point is here. So I've got to find this line that's going to be perpendicular that goes through this point. Figure out where it intersects my line L, and then figure out the distance between those 2 points. I'm going to say it again. First, find the line that is perpendicular to this line and passes through P. Then figure out where this line intersects this black line to get a point. When I get that point, I'm going to find the distance between the 2 points to answer the question. All right, so even before I do all of that, right? I'm sorry for making this sound so huge. I first need to find the equation of this line. And I'm going to use y equals mx plus b just because it's convenient. Not that it's the necessarily easiest, but it's a nice one. So y is equal to mx plus b, where m is the slope and b is the y-intercept. First, I need to find the slope. So I'm doing this of the black line. This is part 1. So if I do that, I'm going to find the slope. We remember slope is change in y over change in x, right? So x of 2 minus x of 1 is at the bottom of the equation of the formula, and y sub 2 minus y sub 1 is at the top. All right, that's squared. Is at the top. There we go. All right, so now what I'll do is just do change in y over change in x. So m is equal to, in this case, negative 6 minus 3 over 4 minus a minus 5. When I do that, I get a negative 9 at the top and a positive 9 at the bottom, which tells me that my slope is a negative 1. Put negative 1 in for m, which is the slope, and then I'm left with an equation that has y and x in it, but I need b. And so to get b, I'm going to take either one of these points. Let's use the first one, and I'm going to plug it in for y and x. So I have a 3 for my y, and then for my x, I have a negative 5, and I'm going to add the b. When I multiply this, this becomes a positive 5 plus b is equal to 3. Finishing this off, subtracting 5 on both sides, I get that b is equal to negative 2. So with that in mind, I have the equation I need. Y is equal to negative 1x, remember that's my slope, plus or minus 2, which is my y-intercept, which I just found out. So with this, I'm going to actually erase this work, and I'm going to go to the second step. So my second step is to find the equation of the red line. So I'll do this in red. And again, I'm going to put it in y equals mx plus b form. Realize that the slope of this is negative 1. Therefore, the slope of this is a positive 1. Remember that the slope of two lines that are perpendicular will be opposite reciprocals, opposite sign, then take the reciprocal of the number. And then so now I've got part of this equation together. I got 1x plus b. I need a point in order to find this b value. The point I'm going to use is 2, 4, because that's the only point I got. So I put a 4 in for y, and I put a 2 in for x, and I solve, and this is going to be a quick solution. I'm going to end up getting rid of 2 on both sides, right? And b is equal to 2. So my equation here is y is equal to 1x, or I can just put x plus 2. So now that I have these two equations, the next thing I need to do is figure out the intersection point. To find an intersection point, I basically have to use systems of linear equations, which tells me that I can set equations equal to each other if I have them solve for the same variable, which I do. So negative x, I'm just writing that negative 1x is a negative x minus 2, is equal to x plus 2. Because at some point, the y's are equal here. Therefore, if I substitute the y's, I get negative x minus 2 and x plus 2. This is substitution method, something you may have talked about in algebra. So then when we do that, we're left with negative 2 is equal to 2x plus 2. Get rid of the 2 on this side, and I've got that 2x is equal to negative 4, which tells me that x is equal to negative 2. That's just the x term of this point, though. So the x term is negative 2. You can see my graph is off a little bit. We need to find the y point of this, the y coordinate of this point, and I do that by plugging in the negative 2 back into either equation. I'm going to do this one just because it's there. Y is equal to negative 2, plug in the x term, and I'm looking for the corresponding y term. I get 0 here. Y is equal to 0. So when x is equal to negative 2, y is equal to 0. That is my point. Now, the last portion of this problem requires us to find the distance from these 2 points. And so we've got this point, we now know what this point is, and to find the distance, we will rock a little bit of the distance formula. You remember what it is. There's our distance formula right there. X sub 2 minus x sub 1 quantity squared, y sub 2 minus y sub 1 quantity squared. The sum of those, the square root of that, boom, boom, right? So let's go. So if I'm talking about the distance between these two things here, what I'm going to do is use these 2 points. And so simply put, the difference in the x's would be 2 minus a minus 2, right? 2 minus a minus 2 quantity squared, and the difference between the y's would be 4 minus 0 quantity squared. So I end up with 4 squared here and 4 squared here, which is 16 plus 16. All of this is still underneath the radical. My apologies for being sloppy math teacher. And then we get that's equal to the square root of 32. And we could leave that like that. We could approximate the value. We could do some ways of simplifying it. Let me simplify it just for kicks and giggles. I'm looking for a number. What number goes into this guy? That's a perfect square, 16. So I can look at this and say this is really 16 times 2, and I'm taking the square root of it. Remember, I can take the square root over multiplication, but not over addition and subtraction. When I take the square root of 16, I get 4. So my answer is 4 root 2. The distance between these 2 points would be 4 root 2. I'm going to read over this key concept, and here's a little interesting development in Theorem 3.9. The distance between parallel lines. So the distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So if you've got two lines that are parallel and you want to talk about the distance between these two lines would be the distance between one point on a line and just the other line. So basically a perpendicular distance. So that's stated in words, but I think intellectually you would have understood that, right? Let's look at this theorem, Theorem 3.9. Two lines are equidistant from a third. So if in a plane, if you've got two lines that are equidistant from a third line, then those two lines are parallel to one another. So if two lines are equal in distance from a third line, then those two lines are parallel to one another. It almost sounds like, so we have this line here, and I say, well, the distance from this line to this line and this line, kind of like my house and all these, right? And the Goodwill, the distance from here is the same, and these guys are consistent. Then these, what we know is that these two lines are parallel. All right. So let's go ahead and look at our third and last example. We're going to find the distance between the parallel lines L and M with the following equations. So let me graph this first line, L. We know that the y-intercept is 1 and the slope is 2. So we go up 2 over 1, up 2 over 1. So the graph of this line should look something like this. And then this orange one, the y-intercept is -3. So we start down at -3, which is here. And the slope is the same, up 2 over 1, up 2 over 1. So this line should look like this. So here are two parallel lines, and what we need to do is find the distance between the lines. So what I do know is I know I've got 2 points here. One point, the point on this green equation, is going to be the y-intercept, which is 0, 1. And the point on this orange guy is going to be 0, -3. Now, what these points give me is just an opportunity to do the same thing that I did in the last problem, where I had a point, I figured out where the, let me do this in a different color, where the line, where this blue line intersects this orange line. So then I find the equation of this guy, I know the equation of one, I find the equation of the other, find their intersection point, and then I can find the distance. So we're going to do the same thing. So I'm going to use this point, 0, 1, not this point. I could have, but not 0, -3, but I could have, but I didn't. I'm going to use this point, and I'm going to find the information we need. So let's go. We're going to find the equation of the blue line. Knowing that the blue line is perpendicular to these two, these other two equations have a slope that is equal to 2, right? We can see that. Therefore, the slope of the blue line has to be equal to -1/2. So I'll start off there, and then I'm going to plug it away. At y is equal to -1/2, x plus b. I'm going to plug in this point that I know is on the blue line. When I do that, I get that b is equal to 1. So here's my equation right over here. And now I'm going to erase the rest of this and get to the next part. Part 2 is to find this red intersection point, which is the intersection point of the blue line and the orange line. So I'm going to use these two equations, set them equal to each other, then solve for x. With a little bit of fun, I get that x is equal to 8/5, and now I'm going to find y by plugging 8/5 back into either one of these equations and solving. So the point that I'm getting is 8/5 and 1/5. And what this 1/5 is showing me is that my graph is not nice. It should have been kind of much higher up here for the intersection point. But whatever, 8/5, 1/5, I'm going to trust my algebra using the distance formula and these 2 points. Okay, a lot of work and a lot of fraction fun gets us down to the idea that the distance is 1.8. So my hope is that this makes sense. I'm going to stop here. Feel free not to turn in notes for this, but make sure you understand. Make sure you understand what's going on, and I will be sending your test out quite soon. Take it easy. Bye-bye.